Good morning, class. We'll continue with chapter 2, NumPy library from Python. So these are the learning outcome and then content. There are 5 subtopics that we're going to cover in this chapter. Okay, NumPy library. The definition. NumPy basically is a numerical Python. The short form is NumPy. We call it a NumPy because it's a numerical Python. So when it's come to numerical, we know that it's all about numbers, right? It's a fundamental package for scientific computing in Python. It provides for support for multi-dimensional arrays. Okay, you can see here, basically it's dealing with arrays and matrices along with collection of mathematical functions to operate on these arrays efficiently. The description for NumPy, it enables high-performance computations using optimized C and Fortran code, support large and multidimensional arrays, provides functions for linear algebra, statistics, and random number generation. And this is the most important part, why we are learning in this particular course, okay, data programming 2, because it's dealing with data science, machine learning, and numerical analysis. Okay, this is the basic syntax for NumPy, which is you first need to import the NumPy using the following command. Okay, import NumPy as np. Okay, either you can import, you can write up to here, or you can write full. Okay, import NumPy as np. np is a short form of NumPy only. Okay, creating NumPy array. A NumPy array is a grid values of all the same type indexed by a tuple of non-negative integer. So first of all, we import the NumPy and then create the array. Array equal to np.array. So this is a one-dimensional NumPy. One-dimensional. Why we call this as a one-dimensional? If you write, the output will be this one. Can you see? 1, 2, 3, 4, 5. So it's like a single row. So it's a one-dimensional. The heart of the library. The core feature of NumPy is the ND array, n-dimensional array, which provides fast and memory-efficient data manipulation. It supports various data types such as integers, floats, and complex numbers. It uses vectorized operations to improve performance over Python list. Okay, I guess you have learned list before. Okay, there's one feature called list in Python. You already learned in your basic Python last semester. Supports broadcasting, allowing operations on arrays of different shapes. So we have a multiple shapes in arrays. Okay, let's see. Creating a two-dimensional array. Array 2 dimension is equal to np.array. So just imagine that we already import, okay, the NumPy. So 1, 2, 3, 4, 5, 6, print array 2D. So this initializes a two-dimensional array matrix and prints it. So usually the output will be look like this: 1, 2, 3. Okay, and then the second row will be 4, 5, and 6. So it's look like this. So row number 1 and row number 2. So this is what we call as two-dimensional array. Indexing in NumPy. Okay, so we'll learn one by one. Indexing, slicing, and iterating. Indexing refers to accessing individual elements an array using their positions. If you learn about C++, Java before, so you have come across about indexing. Okay, and remember the index is actually to identify the position. For example, you have like 1, 2, 3, 4, 5, and 6. Okay, let's just imagine the first position. So in this first position, the value is 1. So the position is the one is called as index. And remember, in programming, C++ or Java, even in Python, the first index always start with 0. Can you see? So when the index is, when the index equal to 0, so the value will be 1. So this is 0, 1, 2, 3, 4. So when you count, there are 5 elements, but the index start at 0. Remember this. Okay, for example, accessing a single element, array 2. So 2 means start with 0, 1, 2. So the answer is 15. Explanation: the element at index 2 is accessed. Moderate example. Second example here. This one is one dimension. Now we're going to see on second dimensional. When it's come to second dimension, so we'll see index 1, 2. So the output will be, so we have 1, 2, 3, 4, 5, 6. So 0, 1, 2. 0, 1. Just imagine this one. So first position or first index, and then comma second index. Alright, so the output is 6. Boolean indexing. Boolean indexing is retrieve elements greater than 20 using a Boolean mask. So if it is agree, then it usually apply that. So if the array is greater than 20, which means 10, 20 is excluded because it's greater than symbol. So the output will be 30 and 40. So this is the output. So this is how we access a single or multiple elements from Python or a data set using NumPy. Slicing. Slicing means we try to extract. We try to retrieve the value. Extracting a subset of elements from an array using a specified range. It start, stop, and how many steps there. So omitting start begins from index 0, omitting stops selects until the last index, and omitting steps assume step size of 1. Let's see an example. Example 4.1. From one dimensional array equal to np.array 10, 20, 30, 40, 50. So array start at 1 and at 4. Remember, when you are n at 4, see this explanation. You can only take up to position number or index number 3. So let's write the index 0, 1, 2, 3, and 4. And stop at 4, right? So which means you have to exclude number 4. So which means you only count up to from position 1 to 3 only. 1, 2, and 3. So the value will be 20, 30, 40. So this is the output here. Slicing two-dimensional array. So let's see the output. If you run this code, definitely you will get the output automatically. But you just need to understand how do this slicing is, we do the slicing. So we have two-dimensional array here with 1, 2, 3, 4, 5, 6, and 7, 8, 9. With array start from 0 index, finish at 2, which means it only count up to 1, and 1, 2, 3, so which means it count only 1, 2, 2. So 3 is excluded, 2 is excluded. So the output will be 2, 3. So 0, 1, 2. Correct? Okay, and then so it's start with 0 to 1. So the output will be 2, 3 and 5, 6. So it's extract element from the first two rows and second, third. Okay, first two rows and second, third. Advanced example, slicing with a step. Okay, so far we have come across, right? You can see start and stop only. Now we will add on with one more step. Okay, so array equal to np.array 0, 5, 10, 15, 20, 25. So it extract every second element. So which means that dot, okay, colon, which is there's no any position they restricted, but the steps given here, every second element should be counted. So 0, 1, 2, 3, 4, 5. Right. So every second element is counted. 0, 10 and 4, which is 20. So you can see the output. Okay, next, iterating in NumPy. Iterating refers to looping through every element efficiently. So NumPy supports for loops and n-dimensional iteration for iteration. Okay, so this is the way to write the code or the syntax. Iteration over multi-dimensional arrays occurs row-wise by default. A row, so this is row and this is column, correct? Row and column. So they say row wise by default. Basic example number 1, 5. Number 1, one-dimensional array. So for num iteration, for num in array, okay, array we already declare here, this one. Print num. So it's loop through and print each element. So it go through for num, data type num, in array. So it just loop. So it print out all the values again, 10, 20, 30. So that is the loop. Next. Second example, iterating over two-dimensional array. It's iterate through each row in 2 dimensions. So it's go through row by row. For row in array 1, 2 and 3, 4. So it's just print 1, 2 and 3, 4. We will do practical also. So this is just an example for you to understand the basic concept of slicing, iteration and also the indexing. For array equal to number 3, array equal to np.array 1, 2 and 3, 4. So just imagine this is a matrix. Okay, then only easy for you to imagine how would you able to get the answer for this or output. For num in np.nd iteration array print num. So this ensure the element wise iteration over multi-dimensional arrays. So it print out all the elements over the iteration from this particular array. Next, reshaping array manipulation. Manipulation means we try to modify or change. Reshaping is a process of changing the structure of an array without altering the data. Okay, we are not alter the data, but we are alter the shape of the array. This is a syntax, numpy.reshape array, comma new shape. Okay, let's see basic example. Import numpy as np array equal to np.array 1 2 3 4 5 6. Reshape array equal to array. We already declared the array, right? So arr dot reshape 2 comma 3. So the original array with 6 elements reshape into 2 by 3 matrix. Okay, so the printed output will be, what is 2 by 3 matrix? So the 2 by 3 matrix okay, so the 2 by 3 matrix will be 1 2 3 4 5 6. Am I right? So this will be the 2 by 3 matrix. So from single dimension converted or reshaped to 2 by 3 matrix. Next, this example, array equal to np dot arrange 12, reshaped equal to array dot reshape 3 comma 4. Okay, 3 comma 4 and reshape, print the reshaped array. So we are going to create with 3 rows and 4 columns. 3 rows, 1 2 3 and 4 columns, 1 2 3 and 4. Right, so 3 columns and 4 rows. So we create an array from 0 to 11. Why 0 to 11? Arrange 12 here. Right, so it can be 0 1 2 3 4 5 6 7 8 9 10 11. Got it? Okay, next, the last example here, arrange 24 with 2 comma 3 comma 4. Okay, this reshapes a one-dimensional array into 3-dimensional structure. 2 blocks of so which means there are 2 set of 3 by 4 matrix. Okay, 2 set of 3 by 4 matrix. So the final outcome will be 3 by 4 matrix got 2 set. So which means set 1 we have 3 by 4 matrix. Set 2 also got set 1 and set 2. So the output will be like this. You guys can go through from 0 to 1. So 0 to, for example, it should cover 0 to 23 only. Yeah? So 3 by 4 matrix will be 3 rows and 4 columns. Correct? This one row and columns. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So should be 12 to 23. Flattening arrays. Flattening converts a multi-dimensional array into single dimension. Previously, we tried to modify from single dimension to multi-dimensional. Now back to the, multi-dimension back to single dimension. Okay, we use flatten the syntax. Okay, the first example, np.array 1, 2, 3, 4. So it's written back. You see, flatten array equal to array.ravel. Print the flat array. So the ravel is the one written, ravel is the one written, the view of original data, which is back to single dimension. 1, 2, 3, 4. Okay, this one is separated. You can see separated, right? Now it will become 1, 2, 3, 4, something like this. Next, flatten create a new one-dimensional array from multi-dimensional one. Okay, this one is multi-dimension, you can see. right? So from this multi-dimension, it become one single dimension, everything in one row of elements. The last one is flattening using column major order of F instead of default row major order. So we'll see this in our practical session later on. Joining arrays is concatenate. Joining means combine the two arrays into one single array. So this is an example of concatenate. You can see array 1, array 2, concatenate, which means combine. So these two array combined, it becomes join array. Two one-dimensional array are combined into single array, which means 1, 2, 3, 4, 5, 6, like one single line. Okay, so the other example you guys can go through. Split the array. Just now we combined, right? Concatenate. Now we have an array, so we want to divide into multiple smaller arrays. Okay, for example, array into two equal parts. For example, when we have a 6 elements, when divided by two equal parts, it will be here, right? 1, 2, 3, 4, 5, 6. This is how we do split. So we use the keyword called split. And we have V split and H split. V split is for vertical, H split for horizontal. So also you guys can try this. Adding and removing. Okay, we try to insert and delete, add insert new values or eliminates them. Okay. Okay, insert 99 at index number 2. Okay, so currently we have 0, 1, 2, 3. Right, so we try to array. For this array, we want to insert at the second position. Second position is number 3, which is 99. So it print the new array. Okay, next. Insert row 9, 9 at index 1. This is the second example here. So 9, 9 at index number 1. So instead of one particular position, so it's changed to two values, two elements in the two-dimensional arrays here. Okay, so next. Reading and writing array data in files refers to the process of storing NumPy arrays persistently in a structured format and retrieving them when needed. This is crucial for data analysis and machine learning tasks where large data set must be stored and accessed. Reading and writing means save the data set. Okay, you can edit or modify the data set. Okay, the data set can be two primary file format, binary file and text file. Okay, binary file can be NPY or .npz, or text file can be .text, .txt or .csv file format. Okay, writing NumPy arrays to files. NumPy.save file name, comma, array. So import NumPy as np, data equal to np.array. So this is our data. And we want to save this data into npy format. Okay. So your file name is data. Okay, your file name here. So this is your file name, data.npy. And your array is your data here. This is your array. So just right here. So this saves the data array in binary format as data.npy, which can be loaded later on. So if you want to moderate usage, saving multiple arrays in a format. So we have array 1, array 2. So multiple arrays.npz. This store multiple arrays in a single compressed file. Okay, zip file. So array equal to array 1, array 2 equal to array 2. So this is how we store multiple arrays in a single file. Serving arrays in text format. Okay, similar to the previous one. np.save, right? You can see np.save. But in this case, okay, this one is save z because it's a zip file or compressed file. For text, and CSV, we use save text, okay, matrix.csv, where it is a matrix. Okay, this matrix in a CSV file separated by commas is a delimiter equal to comma, making it compatible with spreadsheet application. So this is how we save text file and CSV file. Okay, we already save. Now we already writing the file. Now we need to read the file which we already saved before. So numpy.load file name, okay, loaded equal to np.load. So just now we saved the file name as data.npy, right? The first example. So we just load the file np.load bracket load data.npy print loaded data. So this retrieve the previously saved data.npy format data and prints the content, okay, because it's print. Okay, example. Explanation. This loads npz file, okay, the zip file or the multiple arrays file, array 1, array 2, the output, the first output and second output, you can see array 1 and array 2. Okay, but we still call the same file. Okay, inside one single file we have multiple arrays, so you can load that. For the CSV file, this one not CSV, sorry, this one is a text file format. NumPy.load text file with the delimiter. Okay, so we load text matrix CSV, because previous example we saved the file as matrix, right? .csv. So matrix.csv delimiter equal to comma print loaded matrix. So this reads CSV file and reconstruct it as a NumPy array for further processing. Why we need to call the file and save the file? It's for future references and users. So we need to know how to write a file and read the file. Okay, this is the last part of this chapter, real data set application with NumPy. So what we can apply, how do we apply this NumPy in our real data set? NumPy can be used to handle a real world data set, perform numerical computations, and analyze large data sets efficiently. So let's see. We're going to utilize a built-in data set from scikit-learn and Seaborn. So NumPy, import NumPy as NP from sklearn. Sklearn is actually scikit-learn. Scikit-learn, import dataset. Inside the dataset itself, we have a iris dataset equal to datasets dot load iris. Okay, iris underscore data equal to iris dot data. Extract the numerical data and display the first 5 rows. So you can leave it blank, colon 5, which means first 5 rows. So it uses the built-in iris dataset from scikit-learn, extracting only the feature values: cephal length, cephal width, petal length and petal width. Print the first 5 rows. Okay, so we already declare print 5 rows only. So the basic computations, computing basic statistics on iris dataset, you can do mean, standard deviation. Okay, this one is like column wise means and column wise standard deviation. So we use np.mean, np.standard deviation. Filtering flowers with petal, the length which is greater than 1.5. So we try to filter out, select the rows where the petal length is greater than 1.5. So you just extract only rows where the petal length from the third column exceeds 1.5 cms, showing flower with relatively larger petals. So this is how do we apply NumPy in real data sets. Okay, so as a conclusion, NumPy is a powerful library for numerical computing. It provides efficient data structure and mathematical operations. Understanding indexing, slicing, and manipulation is essential, and NumPy supports seamless data storage and retrieval. Applying NumPy to real-world dataset enhances data analysis capabilities. So far, we are done with NumPy. So we'll do with practical NumPy practical later on. So the next coming chapter will be Pandas library for data manipulation. Thank you.